Hi, welcome. I know why you're here, and it's not to learn calculus, it's to join me in the simultaneous sip. So if you have your coffee ready, please join me. The question we're working on today is, sketch the graph of the function f of x equals x to the 1/3 times x plus 4. So we'll begin this question by writing down the function. F of x equals x to the 1/3 times x plus 4. And the information we're going to look for is when our function is increasing / decreasing, local max and min, where it's concave up or concave down, and the points of inflection. Off camera, I found the first and second derivative, and so what we need to do is we need to figure out when our derivative is equal to 0 and when it doesn't exist. So f prime of x equals 0 when x equals -1. F prime of x is undefined, well, when the denominator is 0, so when x equals 0. Okay, and then the second derivative, we're going to do the same thing. So f double prime of x equals 0. So this is when the numerator is equal to 0, so x equals 2. And similarly, f double prime does not exist when the denominator is 0, so that's when x equals 0. So what we do now is we draw out a number line, and we break it up at each of these x values. X equals -1, x equals 0, and x equals 2. And what we'll do is we'll take a test value from each of these segments of the line. So our test values could be -2, -0.5, 1, and 3. And what we need to do is just check for the sign of the first derivative and the second derivative at each of these test values. I made this chart here between scenes, and what we'll do is we'll take our test values and plug them both into the first derivative and the second derivative and just mark down if we're positive or negative at each of these values. So we'll take -2, plug it into f prime, we get a negative over a positive, that's a negative. We'll plug it now into f double prime, we got a negative over a negative, that's a positive. And now we can just repeat this for the next three values. So if we plug in -0.5, we get a positive over a positive, which is a positive, a negative over a negative, which is a positive. Plug in 1, positive over a positive is a positive, a negative over a positive is a negative. And when we plug in 3, we got a positive over a positive, which is a positive, and a positive over a positive, which is a positive. Okay, so on this part of the line segment, we're decreasing and concave up. So our curve will look like that. In this part of the line segment, we're increasing and concave up. In this part of the line segment, we are increasing and concave down. And in the last part of the line segment, we're increasing and concave up. The next thing we should do is figure out which point corresponds to when x equals -1, x equals 0, and x equals 2. So those are the points -1, comma, -3, 0, 0, and 2, 6, cubed root of 2. So I marked those points in onto a Cartesian plane, and we're ready to sketch our curve. So from the left of -1, our curve will look like this. Between -1 and 0, here. And our derivative was undefined at 0, and it turns out that it's a vertical tangent. From 0 to 2, our graph looks like this. And from 2 to infinity, it looks like this. Okay, and so this is the sketch of our graph. We could use Desmos to actually plot the graph using a computer, and you would see that our sketch is really not that bad. Well, thanks for stopping by. I'll see you next time. Don't text and drive. Bye-bye.